Hey Vamshi,
Hi, hi, Andy. Good morning.
just wait for 2 minutes, huh? I'm just checking with others, huh?
Okay, no problem. Yeah.
Hey, good evening, Manish. I think Kundan joined. Hey, Kundan.
Good evening, Shini.
Good evening,
Shini,
sir.
this is related to Snowflake, right? Not
Uh,
data science
No, no,
class.
no. It is Snowflake only. Just a
Okay, so that is at 10:30, no?
true.
Okay, okay. Actually, I got confused and joined this.
It's okay. You can stay here if at all you want.
Okay, okay,
No problem.
okay,
Up to you. So
okay.
one more person is joining, and I'm just waiting for him. Okay.
So, what is the topic that you are teaching
Okay, we are
today
just giving.
on Snow?
I'm just going to give a high-level introduction about Snowflake and data engineering and the Snowflake new features. All this.
Okay, okay, fine.
It is up to you. So you can stay or
Okay, Shini.
yeah.
Yeah. Okay, thank you.
Yeah. Okay. Okay. So let us start. So today I just want to give you a high-level overview on the Snowflake under data engineering, and also I will try to give you a overview on how Snowflake is different from other cloud databases. Plus, we also will discuss about what are the different Snowflake features available, and we'll try to see what topics we are going to cover as part of this particular training. Okay, let me share my screen. So I hope everybody here, like I think Vamshi, I think Manish and Sai, you know about me. I'm not sure about Kundan. So Kundan, uh, I hope you are part of the community also. I hope you got some idea on like about my interaction and all. So I have nearly 20 plus years of IT experience. I come up with a combination of data engineering and data science, and I teach almost all the data technologies where Snowflake is where my primary technology, and along with I also teach data science, Python, and AWS data stack, DBT, and some part of Python as well with respect to data science and data engineering. So to start with today's class, let me share my screen. We in the data era, if you go and see majority of the data engineering projects, if you see when they started in the initial stages, there was no data warehouse, there was no big data, there was no any data lake, all this stuff. Even there was no even database also. So people were start when they started the data collection and data management, majority use it to manage with electronic files, and people use it to like manage with the external device like floppy disk, and there were so many challenges in maintaining the data. So whenever the first database was started, right, I'm talking about the database, and which is called DBase in 1980s. The main objective for DBase is to store the data, manipulate and retrieve it back. So the same DBase database has been converted into a graphical user interface, and people started calling that as FoxPro. So the DBase, FoxPro were the initial databases in the market, especially in banking sector. If you want to see in 90s, FoxPro was very popular. And whenever Oracle came to the market with the fundamental foundation of FoxPro, it became very popular with its security and other features. And slowly, FoxPro became obsolete, and Oracle became the one of the topmost leader in the database side. And with the success of Oracle, we also got other databases like Oracle. Since it is very popular, we got like a database like SQL Server from Microsoft, and we also got PostgreSQL, MySQL, and then Sybase. All these came into the market with relational database features, and all these databases help the companies to store the data at the same time leverage for their application development. This is what the motivation for most of the companies from 90s to 2000 decade. every company started centralizing their data in the databases, and their objective is to how to use it to maintain their applications. That is what happening. And most of the companies were success in that area. And even I was part of database Oracle for some time, and in my initial stages, I worked on Oracle PLSQL development. And whenever we moved to the 2000 era, 2000 decade, the people were started thinking about how to analyze the data. The traditional databases were not supportive, and every company started thinking like, what is the alternative solution? So to analyze the data, if I go back and I want to go and use my real-time data, which is in the database, that will be more frequently keep on changing. So my analysis will be wrong. So that is where people started looking for data warehouse. So a data warehouse was started. The birth of data warehouse happened in the early 2000s, where every company started separating their data into another database and started calling that as historical database, which is a data warehouse, a warehouse with some the data, historical data, like last 5 years or 1 year. So every company started storing the data, and also they started centralizing the data, only historical data with the OLAP capabilities, online analytical processing capabilities, where the data will not be frequently changed, and where that will be used for only analysis. And we will see the historical data, and any real-time data you want to go and analyze, you need to connect to the real-time environment. So once after this data has been centralized, where it was centralized, people used to leverage the databases like Oracle, SQL Server, and some set of CSV files to store this data. And as soon as data has been stored and how it is getting processed, people started using the popular tools like ETL tools like Informatica. Power Center was very, very popular. And at the same time, Data Stage and SSIS, BODS, all these tools became very, very popular. And after this data has been centralized into conventional data warehouse, the reporting tools also became very popular, like the BI tools, like Crystal reports became very popular, and business objects, and then MicroStrategy, SQL Server reporting service. All these major services, they started giving a provision to generate the reports, business intelligence reports. And the sources for this data is internal products and then CRM applications of the company. And slowly every company started building their own enterprise level data warehouses. And what was the structure of the data here? The structure of the data was only rows and columns. There was no any unstructured, semi-structured data in this time period. And even the required knowledge for this particular data also was, if you know Oracle SQL, PLSQL with Informatica, you can easily work on the data warehousing projects. Even TSQL with SQL Server also was one of the combination. And even the data loading frequency, if you see data loading frequency means how frequently you are refreshing your data warehouse with the real-time database. This usually used to happen on a batch data loading. Batch data loading means every day the team used to wait for the daily transactions to load into the real-time database, and from there they used to have a batch process to collect and refresh the enterprise level data warehouse. This used to happen on every company. It can be daily batch or a weekly batch according to the availability of the business data. Like for example, after business hours. After business hours only people used to run. And this is made most of the companies to build their enterprise level data warehouses, and every company was success, and every data warehouse started helping the companies to build their own reports as well. Whenever people moved to the 2010 decade, there was a big revolution in the data. So if you see in the early 2000, after 2010, the birth of big data happened. and suddenly there was a high data growth. So why? So someone is speaking. Who is that? So suddenly there was a high data growth after 2010. So that is the reason behind that is social media. The social media became one of the biggest reason for high sudden data growth, and then because of Facebook, Twitter, Instagram, WhatsApp, and then YouTube, every company started giving provision to upload videos and documents and images. So every individual started uploading on their own choice, and because of this applications, mobile applications, data suddenly got increased. And even to maintain this particular data which is not in structured form, like image is not structured, it is unstructured, document is unstructured, video unstructured, voice unstructured. So to store this kind of data, I can't use traditional databases because traditional databases were developed for storing structured data like rows and columns. So I can't store any unstructured data. So people were looking for an alternative databases to store this kind of unstructured data or semi-structured data. So a big data framework came to the market, like Hadoop came to the market. HDFS and MapReduce both came to the market, where HDFS, Hadoop distributed file system used to store the data, and then MapReduce is the process framework that used to process the data in the HDFS. And these two became very popular frameworks in the early 2010, if you see. And slowly, when MapReduce was having some challenges or limitations in processing, Spark came to the market slowly, and Spark started replacing with Scala, and MapReduce slowly became like obsolete, and PySpark is very popular now. PySpark with data, Hadoop. So that is the very popular combination for managing big data in the market now. And after the success of this big data, we also got advanced BI tools also, like MicroStrategy and Power BI, and Tableau, ClickView, and Google side we also got Looker Studio. All these started giving provision to generate reports on the big data side. So this particular reporting tools also got changed. Where crystal reports was people used to leverage, after big data came, slowly people migrated to is Power BI and other tools. So what were the sources for big data here? The internal products, CRM applications, social media, all became the sources for this particular big data lake or big data warehouse. And semi-structured data, unstructured and quasi-structured data, these three different types have been included in the data type list. Only before this, only structured data was people used to process, which is in rows and columns. As soon as big data came to the market, we got to process even semi-structured data. So any idea what is semi-structured data? Anyone?
JSON.
Very good. JSON, Parquet, Avro, ORC, XML. All this will fall under semi-structured. So this kind of data I cannot easily process in database like tools. I need a separate kind of tool. So that is where Hadoop gave some provision to process these JSON files and Parquet files, XML files. So Hive was one of the framework became very popular. And the challenge with most of the required knowledge to work on this big data environment also is Java, you should know. So Java is one of the very popular like language in the big data side, but slowly what happened after the demise of MapReduce, Spark came with support of Scala, and slowly it also got replaced by PySpark now. Python is Spark. The market is slowly moving to PySpark with big data. If you go and see, even Scala also now people are you can see very limited people are using. So that is majorly where people got like a requirement to use big data, and the data loading frequency in the normal data warehouse was only batch data loading. But here, after big data came into the market, the live data loading streaming also became very popular. So live data streaming means, so I want example, I'll give you like a credit card fraud transaction detection or money laundering transaction detection. So money laundering is one of the very biggest challenge for banks. Credit card fraud also very biggest challenge. I cannot wait for 1 week and I go and conclude a transaction is a fraud transaction in credit card billing. Or even money laundering also very, very risky. I can't go and say after 1 week there is a money laundering transaction. The bank will not accept it. The customer will not accept it. So I need a real-time applications which can detect these kind of challenges. Anomalies, we call it as anomaly transactions. Which is the credit card fraud transaction. Fraud is a separate anomaly. Or money laundering transaction, which is very, very risky. We need to see how to capture these kind of transactions. To capture them, I need to have a real-time data warehouse or real-time data lake, we call it as. A data lake and data warehouse, both are different. A data warehouse is a database with historical data. A data lake is a data warehouse with real-time data also. I can use the data lake for storing both batch and real-time, and which is a single point of source and where I can store any kind of data like structured, semi-structured, unstructured, any kind of data I can store in data lake. Big data lake. Now you can see Delta Lake, One Lake, many new inventions are coming in the market. Azure Fabric One Lake. Azure, we also have like Delta Lake. So all these because the new integrations are happening. So we also need to shift our path to such kind of new technologies and new like data environments. So the data loading frequency have started batch and live, and whenever we got these kind of facilities, companies started building the real-time applications like recommendation engine, which you see the recommendation engine is very popular now, where you see the recommendations in Amazon. Also Amazon, when you buy any product you get recommendations, correct or not? You get, right? When you buy any product, why can't you buy this product and one more product together? When you buy any product now in any application in online, you will get some recommendations. So these kind of recommendation systems can be built only if you are able to capture real-time data, because Amazon will capture your actions when you go and log in Amazon website and try to purchase something, and you definitely visit multiple pages, you navigate multiple pages, you select some products, you click on them and you review them, and whatever the actions you performed there, Amazon will capture, and that is called clickstream data. And that clickstream data also called as semi-structured data, and that will be utilized by Amazon to understand what is your interest. So a Amazon engineer will try to analyze your actions in their website and try to see what are your interest, and they'll try to recommend you what you may be interested. So for that they need to build a recommendation engine specific to your user. So user-based recommendation engine is required. A user-based recommendation system they will build, and that will help them to understand your interest. So to build such kind of systems, you need real-time data or live data. Can I go and say a credit card transaction is a fraudulent after 1 week? Will the customer accept it? I'm a bank employee and someone called me and they said that there was a fraud transaction in their credit card, and you said you called customer, and then he mentioned that he lost his card, and after 1 week you mentioned that there was a fraud transaction. The customer will not accept it, because the fraud transaction should be blocked on fly immediately. After 1 week means you need to pay So the customer will not accept it because why didn't you block the transaction? Why are you telling now? So this kind of questions will arise. So we need a live data, credit card transactions data to block such kind of transactions. So big data lakes will help us. But this big data lakes in on-premise to maintain, you need to spend so much infrastructure cost. This is not easy because every big data environment in on-premise to maintain that, the challenges will be for first to learn big data for the data engineers. Whoever wants to learn big data, they need to learn so many frameworks like this. Nobody will be ready. A data warehousing engineer, if I ask him to migrate to big data, he will say, no, I don't want to learn because these many frameworks, if at all I want to learn, it is good for me to stay in the data warehousing project itself. I don't want to migrate. Similar to that, the companies also, if you go and see, having so many challenges to maintain this big data ecosystem because maintenance is very hard. Patching, upgrading is hard. Performance requires manual intervention. Finding a technical resource who knows these many frameworks, whatever we saw, is not easy. And finding a person who knows how to manage Hadoop clusters, big data cluster, is not easy. Even if you find them, they are very costly. Rare resource means they demand high salary. Plus, we can't reuse existing people to work on the conventional data warehouse, who are already working on conventional data warehouse, to work on the big data because everybody may not be ready to migrate. So, how Snowflake is becoming next generation of big data? So, Snowflake basically is now supporting all kind of data formats. Earlier, the unstructured was having some challenges. Now, Snowflake is supporting structured, semi-structured, quasi-structured, and unstructured. All it is supporting, including document management, voice management. I can extract some information from a call recording also, voice recording also. I can see what is the customer sentiment by extracting and analyzing their voice in a call record. We have some functions. Recently, Snowflake released a function called AI transcribe. That function can extract some information from a voice also. So AI features are, you can see like Snowflake is they're providing these AI features which are not like earlier. You can't find this kind of features in any other databases. It's not easy also. Just like from the database perspective, how we can implement this, how to extract the information from documents, how to extract the information from voice, extract the information from a video. All these now becomes like a simple self statement, like a database SQL statement. And the live streaming data I can manage with Kafka in both big data as well as in Snowflake. And product stability, if you see in big data side, it is not easy because it is fragile, because ecosystem is very huge. And every day you need to perform the patching, upgrading, and you need to have, sometimes you'll have sleepless nights to maintain the environment. But in case of at Snowflake side, all features are integrated in a single product. You do not need to think about any kind of patching, upgrading, because that process will be taken care by Snowflake team in the background. So no manual intervention to performance optimization, but in big data you have to do that. And data transformations, if at all I want to perform in big data side, I need to write PySpark scripts. But in case of Snowflake side, we already have some GUI tools like Fivetran, Matillion, DBT, and CoolCTL, StreamSets. All tools are already in the market. So I do not need to write the code. Simply pull Snowflake data, extract into that particular tool, and apply the transformations. So plug and play. And supported side, if you see, big data, definitely it depends upon the on-premise and the cloud. So both are like on-premise, it will be definitely restricted, but in cloud, you will have the infinite. And even for the Snowflake also, unlimited data they are supporting now. And resource availability, this is very challenging. So if you go and see on the big data engineering side, you will get people, but you will not get the right people. So managing those many big data environments is not easy. But coming to Snowflake side, the resource availability is very easy because if you want to train anyone, you can easily train. Thus, learning Snowflake is very easy. Very fundamental skill and fundamentals of data warehouse, and you can simply learn Snowflake. So it is just like a database, like other databases. And salaries also, if you see, extremely high for Snowflake, and people are getting very decent salaries. Manish is one example. He got an offer and he joined today. Is Manish, are you available? I think Manish is not there. He left. Manish got an offer and he joined in a company today. He was my old student and he got 20 lakhs package and he joined today in same Snowflake DBT only. Just for 4 years of experience in Snowflake. So the salaries are very extremely high. For Snowflake, if you know Snowflake, DBT, and some part of Python and SQL, that is more than enough. So people are like not looking for you like a big data engineer to know so many tools like Hadoop and AWS and then DevOps. So there are so many things. If you go and see in big data engineering side, they're asking many things. Python, PySpark. So you need to know many and databases. So learning Snowflake will make your life easier because we know on SQL database you can learn all other SQL database very very easily. So Snowflake is a ANSI SQL database. So learning Snowflake is just like learning any other SQL database, like how you are going to learn Oracle or SQL Server, similar to that. So that is how Snowflake is now becoming the next generation of big data. And coming to like Snowflake, why Snowflake people are choosing? So there is like really there are so many reasons because first and foremost thing is simplicity. Very very simple. Using like a Snowflake account is very very fast and very easy. I can easily create Snowflake account within 2 minutes and start using it. If you go to Oracle and SQL Server, you will need to depend on the DBA to first install Oracle and maintain, and they will take hours and hours to create the environment. But Snowflake environment, I can create within 1 to 2 minutes. Plug and play. And flexible cost. Pay as you go. Let's take our postpaid, how you are going to use and pay. Snowflake also offering use and then pay. And scalability. So scalability means normally if you go to any database, you will have a limitation on the data size. Maybe like 50 terabytes. If at all you want to go more than that, you need to upgrade it. There is no other option. You have to stop the entire database server and you have to upgrade from 50 terabytes to some additional terabytes which you want. And number of users also, you need, whenever the number of users increases, you will experience some performance degrade. And workload also increases. So but in Snowflake side, it will be automatically scale up and scale down. You do not need to do that. And elasticity. Elasticity means the size for what you need right now. So what is the correct size? The Snowflake will automatically identify. And the diversity. So the data will be like stored in one location and will be accessed from multiple locations by using any device. I can use my laptop or tablet or mobile or PC, I can use any device. I can start using in one device and I can close it and I can also continue on the device also, which is possible. So one single place for all our data. And coming to like Snowflake follows a unique architecture that is called multi-cluster shared data architecture. And to summarize, Snowflake is a data warehouse as a cloud service. There is no hardware for us to select, install, configure, or manage. No software is required to install, configure, or manage. All the ongoing maintenance, management, and the tuning will be taken care by Snowflake team in the background. We just need to register like how you register Gmail account. You need to use a Gmail and or any or email, and then create an account and start using it. It's very easy. And I don't want to go in deep about this Snowflake architecture now. We'll see in the next class. But how can I go and need to create Snowflake account? How can I start using it? It's very easy. So to create a Snowflake account, you simply need to go to Google. So people think like it is not easy to create Snowflake account. It's very easy. So you go to Snowflake free trial. And here you need to click on sign up now. And you will go to the sign up page here. So you will see here there is a 30 days free trial. And with this 30 days free trial, you also get additional $400 worth of free usage. Plus, you also will get immediate access to the AI data cloud, and which will enable most critical data workloads we can start working on. And I can scale up instantly, which I was talking about scalability and elasticity. I can immediately do them with all the additional like data governance features also. So, but how to start creating an account? You simply need to provide your information. For example, I want to give my regular username and like last Gmail. I'm using that, and I will clearly mention personal learning and development. I'll simply click on continue. So now after clicking on continue, it will move to the next page. Here you can give any company name here, and then choose one of the Snowflake edition. So there are 4 Snowflake editions are there. Here only you can see 3 because Snowflake will not provide the 4th edition, which is a virtual private edition. So you need to reach out Snowflake team to register that particular edition. But other 3 editions you can use anyone. So every edition here will have its own features. So for now I will select enterprise. We'll see about these editions in detail. And then I need to select one of the clouds here. Any one cloud. AWS or Azure or GCP. I clearly need to select one here, because Snowflake will be hosted on one of these clouds. So I am selecting AWS for now, and then region will select whatever the region by default one, and then check this checkbox, and then click on get started. So it will try to create my account. You can skip whatever you see here, and they will send an email. You need to check your mailbox. You might have received one email to activate. So I will go here. So my Snowflake account got created, and I need to wait for my Snowflake new account, which I need to activate it. I'm just clicking on my email. See here, okay. I should receive an email. It's correct email. I don't know why it is not. Usually, you should receive a similar kind of email. We should receive activate your Snowflake account email, and once after your account is ready, you can click on the activate button. So when you click on the activate button, it will prompt you to enter your new username and password, and you need to keep this URL handy. You also will receive a separate unique URL for your account. You need to use that in every time when you log in, and you will be identified with your account identifier here, whatever you receive. So that is where Snowflake will try to identify you in their environment. I don't know why it is taking this much time to. another email. Yeah, you can see here there is a, it went to spam. If you go and see here, there is an activation email. Can you see that, everyone? Just now, 0 minutes ago. You need to click on this and it will be redirected to the Snowflake login page. Here you need to enter your username and password. You can simply select your username. But you can use a,
ఏమన్నా ఓకే ఈ మాది
so here we need to enter your username and password. You can give any username and password. And then click on get started. So this will be going to redirect it to the Snowflake web interface, which is the new interface which Snowflake is offering. And here you will see there are some like default SQL statements are there, which you can see. So when you want to see any data, you can simply go and use any of these particular existing SQLs available to test Snowflake environment. Or if you want to write your own SQL statements, go to the projects and then worksheets. And here you can select plus and you can see SQL worksheet. And here you can start creating your SQL statements. So just like a normal SQL database, you can also run your SQL commands here. For example, I want to create database ingest data. When I need to say control enter, it will run the command. So my database ingest data successfully created, and if I refresh, you'll see the ingest data has been created automatically. If I say demo, it will create with a name demo on the database. And then Snowflake is the one of the database, and Snowflake Learning DB, Snowflake sample data. These three will be automatically created for every new account. Even if you see, your account also will have these three by default. These two
I have a
created.
small doubts.
Yeah, Sai.
Actually, normally in SQL Server or anything, we will see whenever we create any DB, right? We can see by default DBs which were created, master DB or
True.
some other DBs
True.
like. So these are also those
Metadata.
DBs which are
Metadata.
system,
This is metadata.
like system databases.
True. You can see all metadata, account usage.
Okay.
You can see like generate way specific cortex, like specific.
Okay.
These are all schemas.
Okay.
So you can see images, image manipulation. You can see machine learning also here. You can see that.
Yes.
And
ML.
models, ML models. You can see. So there are Snowpark related. You can see here. All these will be automatically created for every user. Every user will have them. And this is this one is sample data. If at all I want to test Snowflake environment, I can use the sample data, because the tables also will be very huge in this particular schema, database schema. If you see here, some tables will be even terabytes also. If you go and see the part 5 GB, and line item you see 159 GB. And if you go and see in the 100 CTL database, and if you see the store returns table, it will be terabytes, 933 GB. Can you see that? This is very
Yes,
big.
yes, yes.
And you can also see store sales is 10.4 terabytes, very, very huge. As a developer, I cannot create this many bigger, right? Correct or not? Can we create
No,
this
we
much
can't.
bigger table? We
We
can't.
can't.
No,
We
we
can't.
need to leverage. If at all you want to learn something on big data, use this kind of tables, and it tests the environment. Because
Okay.
Snowflake is offering a sample data to even test their environment to see whether how strong they are in processing a huge amount of data also.
Okay.
So sample data is one of the example for that. And other, you can see apart from this, you also see a learning DB which they are newly added for who are learning, right? So they can use this database, which is a empty one. Nothing will be there. You can start using this and you can start creating your objects in this database also. And you can create your own. This is a database, right? These two are called schemas. It is one schema. Every database is a collection of schemas. I will discuss about that in the upcoming class. A database is a collection of schemas, and every schema is a collection of database objects. So default, every database will have these two. If you go to demo also, you will see that same two, information schema and public, you can see here. This ingest data also you can see same. Correct or not? Any database, user defined databases will have these two schemas by default. What if I want to get my own schema? I can do. For in the demo, I have public by default, but I want my own schema. I can create my own schema also. So create schema. I want to say dev. So when I run this, you will see a dev schema in the demo automatically created, but it will be empty. This is one way. Through command, we can create, or I can go to the database explorer and I can also create my database objects from here also. I can get my database from here as well. I'll say test DB. See, a test DB created. When I click on this, I can create a schema now. So I can create however I want, QA schema. And here inside that I can create the table also. How to create a table? I can simply go and say, see, whenever I select the schema, it is showing like this. When I select the database, it is showing me the schema. Correct or not? See, according to the object you selected, it will try to show the hierarchy. If I select a schema and it is showing me how to create all the database objects. Can you see that? I can even integrate with Git repository also. I can create a procedure, function, and then tables, views. I can create everything. I can upload images also to process. I can create a Cortex, generate by Cortex service also. Snowflake is offering many different features. What if I want to create a table directly without using a command? I can simply go here, table from file, and browse. And it is very intelligent interface. So for example, this is a credits file. And I'm simply selecting this credit card transactions file. And it came here, 3.7 MB file. And I want to give the name as, maybe I'll give like bank data. So I'll say, I'm just creating that in the testDB QA schema. I can change that also if at all I want. For example, I want to change to ingest data publish schema. So now my table will be created in the ingest publish schema, and this is the table name. It will create a new table because I selected this one, and it will generate the table structure also. Next, and it will identify, see the column names also. Can you see that, everyone? And what are the data types also? It is assigned automatically. So this interface is very intelligent. It knows from the file how to capture the columns and assign the data types. And then it is a CSV file, comma separate value. So it is identifying that too. And simply click on load button. It will create my table. See how many rows it loaded? 81,357 rows. how fast it loaded, you have to say. Is it faster or not? Everyone.
Yes.
Very
Yes.
fast. Very fast. If you go here, view table details, you can see the data also. See? So like that, you can create any tables. I can create any tables like this. So I can load the data. So whatever the table already available, I can even load the data like this. Existing tables. I can load the data as well as I can even create a new table also. Create or load the data. So this is the way how you can manage. You can manage Snowflake databases. I can create, I can do whatever the operations you perform on the normal databases, you can perform everything in this particular Snowflake also. Because Snowflake follows the same ANSI SQL commands, DDL, DML, all commands are same. The basic commands. And creating databases, schemas, tables is very easy. I do not even need to write the commands also that you have to observe here. People say that do I need to write coding? No. The interface is helping now. When I started my journey, seriously, there was no this kind of tools. I used to write the code. Now you have everything ready. And you should know how to use the tool, plug and play. How to drag and drop and how to pull the data and how to use that particular tool. If you know, you are good to go. It's not that much difficult. So this is majorly how you can go and create the tables and how to like manage the environment. And there are so many other features which Snowflake is offering. So the features like, let me show you. So what we are going to cover as part of this particular training is like we will try to learn about, so majorly the Snowflake fundamentals are very important to understand why Snowflake is very like popular in the market. And we also need to understand why it is different from other databases and how it is different. And we just now learned on how to create a free Snowflake account, but I'll again repeat this process and I'll try to explain about while creating what we need to focus more, what edition to select, what crowd to select, and how they are going to impact. You should know that. And the Snowset web interface and how to this interface, how to use this interface, how to create databases, warehouses, tables, and different database objects, and how to manage the environment with role-based access control, RBAC, and how to create custom roles. I want to create a data scientist role, or data engineer role, or DBA role, or finance analyst role, or how to use system roles. So Snowflake provides system roles, how to use them, and what are the different types of accounts Snowflake offering, and how to understand and use that. All this we will learn in the first module. And when we move to the second module, we will try to learn about what are the like cloud platforms that are Snowflake offering, and what is the virtual warehouse, and what is the importance of that, and how Snowflake is going to charge the customer. This is very important, very, very important. And how to optimize your cost, how to reduce the cost, what are the different ways, caching, how it will help us, how to scale out and scale up the virtual warehouse. All we will learn as part of this particular second module. And the third one is basically how to understand about the important feature like data loading and data unloading. These two are very important because data loading is one of the very common process everybody perform in the data warehousing projects. It can be bulk loading or continuous loading or incremental loading or full loading. We need to do by leveraging the Snowflake provided features. I can load any kind of file, whatever you see here, CSV, JSON, XML, Parquet, Avro, ORC, all I can load. So we are going to learn through S3, how to use S3 and load this data. And we also will see how to load the data as a one-time loading using SnowSQL command interface also. And what are the internal stages, why we need to use them, what are the external stages, how to use them, how to create external stage, what are the steps to follow, how can I unload the data from table to S3 bucket. So all we are going to learn as part of this data loading and unloading. And we also will little bit go deeper on the semi-structured data loading like JSON, Parquet, XML, Avron, ORC in deep. And what are the challenges we are going to encounter and how to resolve them as a common issues we will try to learn. This is what in people will ask in interview in the real-time environment. What are the challenges you encountered? How you resolve them? What if I want to continue the process and separate the bad records? How to continue the process without failing? How to automate the process? And then Snowpipe continuous data loading. How to automate the data loading without human intervention? How a process can pick up the files and load. That continuous data loading can be achieved through Snowpipe. We will learn about that. And then partner connect. How to go and integrate Snowflake with other partners like Python, Snowpark, DBT. We also will see like Power BI. How can access Power BI? Can access Power BI? Can access Snowflake data? How to integrate with stream sets and Python also I'll show you as part of Partner Connect module. And then what is a scheduling and how streams and the tasks can help us in scheduling your incremental loading, like change data capture, which is very common in most of the data warehousing project. And what is SCD type and how to implement that. We have different SCD types, how to implement them in Snowflake. And then what are the data governance methods like data masking and secure data sharing? Why we need to go for that? Basically, this particular terminology is for admins, but you have to learn. I'm going to teach even the basic admin concepts also. And cloning, how Snowflake is going to help us in reducing the storage cost by using cloning, zero copy cloning. And a time travel and fail safe, how to restore the data even if you dropped the table or deleted the data accidentally and committed it. But other databases we cannot do that. But in Snowflake, we can restore the data. And what are the table types Snowflake is offering? And then what are views? We have normal views, message views, secure views, and recently, very recently, Snowflake added a type of view called semantic views also. I will even touch that as well. What is semantic view? And I will include that as part of this views. And then clustering and micro partitioning, how to optimize your SQL queries, performance tuning, why I need to go for cluster keys, and how can a cluster key can help me. And we also will try to learn a little bit deeper about Snowflake Python connector and Snowpark connector also. Very important. So this will help you to automate your activities, data pipeline activities. I will show you how to eliminate most of the Snowflake features which will cost you and how Snowpark can replace them by reducing the cost. And how can we leverage the stored procedures and functions, user-defined functions to automate these activities. And then DBT, which we are going to learn about DBT and how to apply some transformations on the Snowflake data, how to create a model, how to test it, how to materialize, how to use macros. And we also will learn an end-to-end project with the Snowflake, DBT, and AWS and SQL. And after that, we'll also learn about the AirFlow and Snowflake integration and how to integrate Snowflake with AirFlow and what are the different components of AirFlow and how AirFlow can help us, which is a free orchestration tool, can help us to automate Snowflake data pipelines. And finally, we will try to learn these 5 projects one by one. By whatever we learned, we'll try to combine them and try to implement these projects one by one. That is what I'm going to cover as part of this particular entire training, and which is going to happen in 40 to 45 hours, not more than that. And we are going to learn each and every topic with use case, and you will see the daily recordings, assignments, hands-on scripts, and you also will receive the assignments in the daily folder, and you will have a regular quiz folder also will be there where you can go and test your knowledge. And you also will receive some sample CVs and resume assistance and some interview questions, and anybody interested on Snowflake dumps also I'm sharing, but that is based on their requirement. And anybody wants to appear in certification, you can reach out to me also. All I will support with your 100% dedication. That's what Manish did, and he got a job now. Clear? And now he's like he joined today, and from tomorrow onwards, he's going to start his Snowflake journey. He was not a Snowflake developer. He was a Oracle PLSQL support guy, and he was a 2 months, almost 40 to 45 days training, and then he got a job now. So if you want to get the same kind of job and position, you need to work hard and learn the daily hands-on, daily practice with learning with scenarios, not like what is what. I'll stop here. Any questions from anyone? You can ask. This is the time for you. I can see Santosh, and then someone joined with name Practice. I think you joined, I think a little bit late. Do you have any questions? And I can see Narayana also. Any specific questions from you? Santosh and Satya Narayana. Any questions? Sanchit?
I have a little bit questions, but I wanna ask you personally, Srini.
Okay, no problem. It's okay. You can ping me. That's okay. How about you, Kundan? Kundan Kumar. Are you there? Any questions, Kundan? I can't hear you. Santosh. And then Vamshi, do you have any specific questions, Vamshi? You can also ask.
No questions for today's session. Yeah.
Okay. So anyway, I'll share this PPT and some documentation, Vamshi. You can go through it. Okay. And if you have any questions, you can ask tomorrow also. It's not a
Yeah,
problem.
sure.
Yeah. And how about others? If you have any questions, you can ask now, because I am here to answer your questions if you have any. No questions? Are we good? Can I who's joined with name Practice?
Hi sir, my name is Shahid.
Hey, Shahid. Okay, Shahid. Any questions, Shahid? I'm just asking because I see your name.
Actually,
Tell me.
actually, I'm still learning big data engineer.
I see.
So
Okay.
I see in the group. So after my big data journey, I want to learn Snowflake also.
Oh, okay. It's okay.
So just
You have any specific
I came
questions, you
here
can.
have a
No,
look.
it's okay. If you have any specific questions, you can ask, Shahid. Because it's not like.
As of now, not.
Okay, it's okay. No problem. Okay, then if you
I
don't
will
have any specific questions, yeah, tell me.
I will reach out to you, sir.
Okay. So you I think you are part of my community, right? So you can reach out to me. No problem.
Yeah, I'm part of the community.
Okay, Shahid, no problem.
Okay, thank you,
Okay,
sir.
thank you so much. And this batch will continue from not tomorrow, from Wednesday. So whoever are like willing to continue, please ping me, and we'll talk, and we'll I because I'm going to create a separate group for this, and you will be part of that group also. Okay. And whoever does not have my number, I just pinged my number here. Hope everybody is part of my group only. I know that. But if whoever does not have my number, I just pinged my number. You can just ping me in WhatsApp. Okay.
Okay, thanks.
Okay, then. Thank you so much, team. Yeah, thank you.
Thank you.